Kia ora tātou. In this video we're going to introduce rates of reaction, which is needed for the NCEA Acids and Bases standard, where we look at three different factors that can affect the rate of any reaction. And we're going to use to go through these three factors, three real-life examples that have happened to me recently. So the first one, last night I was eating risotto. It was in a bowl, it was too hot, and I needed it to cool down. How could we increase the rate of the reaction so that I didn't get so hungry while I was waiting for it to cool down that I just needed to eat it and burn my mouth? How could we increase the rate that this risotto was cooling down? The next example is making cashew cream. So for those of you who haven't made cashew cream, you put cashews in a bowl of water to soak them for ages. That's what the recipe says. Just room temperature water, soak them for I think about 12 hours, and then you whiz it up. Bit of lemon, you get a nice cashew cream, which is like great for a pasta dish. How can we increase the rate at which we're soaking these cashews? These are cashews in there. And the last one is if we're having a meal, maybe a bowl of soup, completely tasteless. There might be enough salt in the whole bowl of soup, but each mouthful there's just not enough salt particles that are reacting with my taste buds. Doesn't taste very good. What can we do in each of these situations to increase the rate of reaction so it's more acceptable? Well, the first one, there's probably a couple of ways that we could do it. What I ended up doing was pushing the grains of rice up to the side of the bowl, or we could, instead of eating the risotto in a bowl, we could eat the whole thing on a plate. And that increases the amount of rice grains that are in contact with the air. So it's only really the rice grains on the top that are able to cool down by letting off steam. All of the ones in the bottom, they're being held in place by the rice grains on top of them. So the more rice grains that we have in contact with the air around them, the faster that's going to let off steam. So this is called surface area. Surface area. The amount of area in the actual substance that is on the surface, and we can do that by spreading it out. So there's some examples of how we can do that in chemistry as well. The next one is making some cashew cream. How can we do that? The recipe says to put it in room temperature water and leave it for 12 hours. Well, instead of putting it in room temperature water, what you need to do is, and my flatmate came up with this idea, just boil the jug. Boil the jug, put some hot water on top of the cashews, then you can take it takes about 5 minutes, soaks the cashews, done. So the next factor is increasing the temperature will increase the rate of a reaction. And the third one, we've got a bowl of soup, completely tasteless. What do? There might be enough salt in the whole thing, but not enough per mouthful. We need to add some more salt. So we add some more salt to the bowl of soup, and that is increasing the concentration of salt in the bowl of soup. So these three things, we're going to look into how we can explain why these increase the rate of reaction by looking at the particles involved, and I'll make different videos for each one of these for the next part of the series. Thanks for watching. See you next time.